Have you ever looked up at the night sky and wondered if there's more to reality than what we see? We move through our world, but is this all there is? Our reality is defined by what we can sense, but could there be hidden layers, unseen dimensions shaping the cosmos? Where are you right now? You might say, in your chair, in your home, on Earth. But we can be more precise, using length, width, and height, the three dimensions of space. These dimensions give our world depth and substance. Without them, reality would be flat and lifeless. But what if your cosmic address has a fourth component? One you're moving through right now without even trying time. This fourth dimension, revealed by Einstein, is inextricably linked to space. It's time to peel back the layers and explore the unseen. Let's climb the ladder of dimensions and uncover the secrets of the cosmos, one step at a time. Let's start simple. Imagine a single point. 0 dimensions, no movement, just a location. Stretch that point into a line, the first dimension. Here you can only move forward or backward. Now stretch the line sideways to create a flat plane, 2 dimensions. In this world you can move forward, backward, left and right, but not up or down. A 2-dimensional being would see only outlines, never understanding up. Push that plane upward, and you get the 3rd dimension, our world, with length, width and height. Now, objects have volume, insides and outsides, and complexity. Each new dimension adds freedom and possibility. Our universe is built on this ladder of dimensions. Everything you see and touch exists in 3 dimensions: height, width, and depth. Our brains evolved to master this space, giving us depth perception and the ability to navigate our world. Imagine a 2-dimensional creature, a flatlander, encountering our world. If you passed your finger through its plane, it would see only a mysterious shape appearing and vanishing. Higher dimensions allow new perspectives. We can see all of a 2-dimensional world at once, but its inhabitants cannot. What's a barrier in a lower dimension is open to a higher one. Our 3-dimensional world feels complete, but is it the whole story? The freedom of 3 dimensions has allowed for complex life and civilizations. But perhaps our stage is just one part of a much larger theater. Your cosmic address isn't complete without time, the 4th dimension. You exist at a place and a moment, always moving forward through time, never backward. Unlike space, time feels like a one-way street, carrying us from past to future. Imagine a cube existing not just in space but across time, a tesseract, its entire history visible at once. We can't see this, we're trapped in the present, remembering the past but blind to the future. Time as a dimension is fundamental to physics, uniting space and time into spacetime. Your path through spacetime, your world line, charts your journey through every moment. Right now, you're drawing your world line, moving through the 4th dimension. For centuries, space was seen as a fixed stage and time as a universal clock. Einstein changed everything, showing that space and time are woven together as spacetime. Gravity isn't a force pulling objects, but the warping of spacetime by mass. Picture a bowling ball on a rubber sheet. It curves the surface and smaller objects follow those curves. Planets orbit the sun not because of a pull but because they follow the curves in spacetime. Gravity also warps time. Clocks run slower in stronger gravity. GPS satellites must adjust for this or their calculations would be wildly off. Einstein's spacetime isn't just theory. It shapes our technology and daily lives. If time is a dimension, can we travel through it? We already do. Moving into the future, 1 second at a time. Einstein's relativity says time slows down at high speeds. Astronauts age a bit less than people on Earth, a real form of time travel to the future. But traveling to the past is far trickier. Paradoxes like the grandfather paradox make it seem impossible. Some theories suggest changing the past creates new timelines, but we have no evidence. For now, time travel to the future is real, but the past remains out of reach. Every astronaut's journey proves time's flexibility, but the past is locked away. The laws of physics may protect history from being rewritten. The future is open. The past is a puzzle. Why can we only move forward in time? The answer lies in entropy, the measure of disorder. The universe moves from order to disorder as described by the 2nd law of thermodynamics. A glass shatters but never reassembles. Your room gets messy, not tidy on its own. The universe began in a low entropy state and has been growing more disordered ever since. This trend gives time its direction, the arrow of time. Our memories, aging, and even life itself reflect this one-way journey. The past is where order was. The future is where disorder grows. You can't unbreak a glass or unlive yesterday. Entropy forbids it. Some theories suggest our sense of time's flow is an illusion. The block universe idea says past, present, and future all exist at once. Reality is a four-dimensional block. We feel time passing, but every moment is equally real, just not yet lit up by our consciousness. This challenges our sense of free will and choice. Some physicists argue that now is a psychological construct, not a physical one. At the deepest level, time may not exist at all. It could be an emergent property, like wetness from water molecules. The true nature of time is one of physics' greatest mysteries. Our journey to understand it is far from over. We've journeyed from a single point to the vast fabric of space-time. The third dimension gives us depth, the fourth, time, carries us forward. This fabric is dynamic, shaping everything from GPS to our memories. Imagine if our journey didn't end with space but continued into new dimensions. The fourth dimension is time, a river we cannot escape, always flowing forward, shaping every moment of our lives. But what if there's a fifth dimension, an invisible realm where every possible outcome, every alternate reality exists side by side? Imagine a place where every choice you could make creates a new world, a cosmic tree of possibilities, each branch a different version of you. Now, stretch your imagination further. A sixth dimension, where not just timelines but the very laws of physics can change. Here, universes with different rules exist, each stranger than the last. In these higher dimensions, the universe becomes a vast, mysterious tapestry, woven with threads of possibility, wonder, and the unknown. What if every choice you've ever made, every path you could have taken still exists, somewhere right now? In the fifth dimension, reality becomes a vast, branching tree. Each decision splits the universe, creating new timelines that unfold in parallel. Imagine standing at a crossroads. To the left, you become an artist. To the right, a scientist. In the fifth dimension, you walk both paths. Every what-if you've ever wondered is real somewhere, sometime, in a reality just out of reach. But the rabbit hole goes deeper still. Beyond the fifth dimension lies a place stranger than imagination, a realm called the sixth dimension. Here, it's not just timelines that branch and twist, but the very fabric of reality itself. Picture a library containing not just every story ever written, but every possible story written in every possible language, with rules of grammar and logic you've never seen. In the sixth dimension, entire universes exist side by side, some governed by gravity, others by forces we cannot even name. In one, light might travel backwards. In another, time could stand still, or space could fold into impossible shapes. Let's try a thought experiment. Imagine you could step outside our universe like a traveler stepping out of a painting and into the gallery. You look back and see endless canvases, some with familiar colors, some painted with unknown laws. Each canvas is a universe, each with its own beginnings and endings, its own rules and possibilities. What would it mean to glimpse realities where the impossible is not only possible, but normal? The fifth and sixth dimensions invite us to see ourselves as more than products of a single timeline, a single universe. They whisper of infinite possibilities of choices not taken, worlds not born, and rules not written. Are we just shadows on the wall of a much larger reality? If these dimensions are real, what does it mean for our sense of self, our place in the cosmos, our understanding of existence itself? Could there be versions of you out there living lives you've never dreamed of? Could there be universes where the laws of physics dance to a different tune? As we peer into these higher realms, one thing becomes clear: the universe is far stranger and more wondrous than we could ever imagine. The next step is not just to look outward, but to open our minds to the infinite, the unknown, and the truly unimaginable. What mysteries await us just beyond the horizon? How do we test these wild ideas? Scientists build experiments and use telescopes to probe the universe. Particle accelerators smash atoms to test relativity and search for hidden dimensions. Astronomers observe gravitational lensing, light bending around massive objects to map spacetime's warps. Gravitational waves, ripples in spacetime from colliding black holes, let us hear the universe. These discoveries confirm Einstein's theories and push the boundaries of our knowledge. The cosmic microwave background reveals clues about the early universe and time's arrow. Every experiment adds a piece to the puzzle. We are cosmic detectives, searching for the structure of reality. Some theories suggest even more dimensions curled up and hidden, shaping the universe in ways we can't yet see. Every time you look up, you're peering across space and time. Keep asking questions. The next discovery could be yours. The cosmos is calling. Your exploration has just begun. If you found this information as fascinating and eye-opening as I do, then don't hesitate to smash that subscribe button for even more captivating science content.